Hello again, everyone. This is part one of video number 4, where I'm going to show you how to build a SWAT-CUP project. But before going through that, I would like to show you that what is what, and give you a little bit of background on these different programs. ArcSWAT and QSWAT, as you know, are GIS interfaces where you build your SWAT model. And if you install ArcSWAT, you're going to get probably in the SWAT folder you have installed it, as SWAT wants you to do, and you get an ArcSWAT folder. In the ArcSWAT folder, initially at the beginning, you have ArcSWAT help, but there are some documents to help you build this ArcSWAT project. And as you know, SWAT has excellent documentation, and you can find a lot of information in the in-out file and in the theory file, where you're given a lot of detail about SWAT. And I really recommend that you look through those before trying to build a SWAT project. If you go down this folder, you're going to have some DLLs that you probably don't have to worry about those, but here you have 4 executable files of SWAT for 32-bit and 64-bit machines. The debug program, as you know, if you have any problem running SWAT, you can use the debug version to see where the problem is. This is a larger compiled version of SWAT. And then you have the release version, where there is a smaller compiled program. And the same thing with 64-bit machines. So when you build your project in ArcSWAT and you run it in ArcSWAT, these are the programs that are being run. So these are your SWAT programs where you installed your ArcSWAT program. Now, when you build a SWAT-CUP project, SWAT-CUP comes with a version of SWAT, which may not be the same as the version you are using. So I recommend that you take these files, either a 32 or a 64-bit release version, you bring it into your SWAT-CUP project, and you rename it to SWAT-EXE, so that SWAT-CUP can recognize and run that. Now you have another folder called database. In this database you have some examples and some examples of input SWAT files, and then you have the all-important SWAT 2012 MDB. Now the ArcSWAT uses this file to give you text in out files, the files in text in out folder, which are actually the actual SWAT files. So your database for ArcSWAT is here, and this is what ArcSWAT uses to write those files. So all of your soil and land use and climate, all those informations are here. And then the rest of these you don't have to worry about. Now, when you build your ArcSWAT project, you get a text in out folder, which is actually the folder that SWAT uses. So SWAT is a Fortran program that runs your model in text in out. So in my case, I have a folder called ArcSWAT projects, where all of my active SWAT projects are here. I have a project here called Mendoza, which I'm going to use. In this Mendoza project, I have built my ArcSWAT, and these are the files and folders that I get, right? When you build, here is the SWAT 2012. This is the MDB of your project. So the information that your project uses are mostly in here. And then you have the scenario and the watershed folders that you know. database is the database of my project. Here is discharge, here is the GIS data that I used to build the project, here is the weather data, and so on. So I would like to keep everything in the same folder. As you know, GIS is about organization, and it is important that you keep, when you build the ArcSWAT project, you keep all your information, including database and SWAT-CUP project, in the same folder, so everything is here, so you don't have to look around in different drives and different folders to get your soil data, land use data, and so on. So it's good to put everything in the same folder. Now the text in out is in scenario default text in out, right? And this is where all of your SWAT input files are. As I said, SWAT is a Fortran program. It uses these input files. So once you have built the ArcSWAT project, SWAT, and created the text in out, then SWAT is completely independent of that ArcGIS, and it uses only these files to run. And if you run your program from the ArcSWAT after you have built your project, you're going to get the output files from SWAT, which is put into this text in out. So when you want to build a SWAT-CUP project, I recommend that you delete these outputs so that this folder only has your SWAT input files, because this folder gets copied into SWAT-CUP project, and you don't want to carry all of these files which are not necessary at this point. So you can just delete them, and they are all nicely highlighted with output with different extensions. And then there is one called watout.dat. For some reason it doesn't begin with output, but this can get become a very large file, so you should delete this one as well. So next, when you have your text in out, then you have your SWAT project, then you want to calibrate it. So here you come into SWAT-CUP and you build a SWAT-CUP project. Now what I'm going to show you is that how you build a project in SWAT-CUP, and why, when you have calibrated your project, your SWAT project in SWAT-CUP, then really everything is here. And there are people asking me, so I now calibrated my SWAT in SWAT-CUP, how do I bring the parameters back to SWAT? So I don't really know what that means, because this is your SWAT. I mean, your SWAT is text in out, and SWAT-CUP just brings text in out and calibrates the parameters which are in text in out file. So at the end, your calibrated SWAT project is here. So there is no reason, or doesn't make any sense to say how do I bring these parameters back into SWAT now? Or even some people want to bring it back into ArcSWAT. As I said, that MDB database has all of your ArcSWAT information. So to bring these parameters back to that database is, first of all, not necessary, and secondly, it's sometimes even impossible, because if you have used relative changes to change your parameters, that means you have changed your soil parameters based on the land use. Now, there is no way you can bring that back into ArcSWAT, and there is no reason for it. I show you that how you can do everything. So you want to use your calibrated model now, you want to do other analysis, climate change analysis, land use change analysis, best BMP analysis, and so on and so forth. So you can do all of that in the SWAT-CUP, because this is now where your SWAT model is. And when you do management changes, all that does is change a few parameters. So you can just change those parameters here much easier than you can do it in anywhere else, and then see the effect of that. So I will show you as we come to that. Okay, now so let's go to SWAT-CUP. We now have 3 versions of SWAT-CUP. It's SWAT-CUP Plus, SWAT-CUP Premium, and SWAT-CUP 2019. When you install SWAT-CUP, you get these icons on your desktop, and on your drive where you installed them, you can get SWAT-CUP Plus, SWAT-CUP 2019, and SWAT-CUP Premium. They all look the same in structure. You have in every one of them, you have a external data folder and a whole bunch of other DLLs and programs that you don't need to bother with. If I go down here, you have the SWAT-CUP executable is down here. If you go to external data, here you will see a folder called references. Here I have the user manual. User manual, really I try to make it so that it explains all of your questions. If you just read it, really everything is here. All the questions that I'm asked, they are all in here. And there is a little bit of background, and then there is a step-by-step explanation of the what you do when you go into SWAT-CUP, how you create a project, how you do it step by step. All the files are explained here. A lot of the concept is explained here. And if you go further down, every step of the way, you will get to the important topic of parameterization. Parameterization, here you will learn what V and A and R means as a qualifier to your parameters, and many people use this very wrongly. It means they haven't read what R really does. They use it incorrectly, and then they ask me about the problem they're having. A lot of examples are given here, and a lot of the objective functions, they're all described here, and so on. So if you just look through this, you will find a lot of useful information, and a lot of your questions will be answered here. Now, the other file is a report that I use to describe the best management options. I will tell you more about that later. And then you have the source data. The source data includes program PSO, and what you have here is a backup folder, an echo folder, iterations, PSO in and PSO out, and a whole bunch of programs that are needed to run the PSO. Backup is your text in out. So when you start a SWAT-CUP project, your text in out is copied into this backup, right? And it never changes to the end of the calibration, so it stays the same. Because when you do relative changes, it's relative to the parameters in the backup. So this backup must stay fixed. That is your original project. You have an echo folder. In this folder, when you run any of these executable files, they echo what they read. So often when you have an error, and I write that, go to the echo and look at the echo file, and you will maybe get a clue to the mistake that you have made. So if you execute any file, you get an echo of that file. So if you come here, you can see what it's reading, if it's reading everything correctly. And then iterations are, you keep track of iterations that you do, and PSO in, you have all the input files. So here's the observed file. You see all of these in the interface, but they are all actually here, and many people seem to be unaware that behind the interface there is a folder which contains all those files, and so on. If you go to the other program, SPE is exactly the same. You have the backup, echo, iterations, parallel processing. With SPE you can do parallel processing, and which is performed in this folder. And then you have the SPE in and SPE out, where all the output files go here. And then you have a whole bunch of programs that you need to run the SPE. So this is short description of what you get. And if you go to any other ones, if you go to other SWATCUP Plus, it's exactly the same. SWATCUP Plus is exactly the same, and SWATCUP 2019, again, exactly the same structure. All right, now let's make a SWATCUP project. I'm going to use SWATCUP Premium to build a new project, and all the other SWATCUPs would be exactly the same, the procedure. So let's start here. Now, as I said before, I have a folder called ArcSWAT project. In the ArcSWAT project, I have all of my active SWAT projects. So in here, I have a project called Mendoza. It's a watershed in Argentina, and I've built the project. This is the ArcSWAT here. That's my database, as I pointed to this before. You have the scenario, default, takes in out. So all I need is here in this folder. Now, when you open the SWAT-CUP, this is SWAT-CUP Premium, you start here. You start here, and we build a new project. The new project, just next. The first thing it needs is the location of text in out. So I just browse the location. It is in ArcSWAT projects and in Mendoza project. And here I have the scenarios, default, and text in out will be highlighted immediately. Next, you can choose either SPE or PSO. Let's try SPE first. Next, it says project name, so I give it Mendoza, and the program will automatically add .spe.swatcup to this. That'll be the full name of my project, and then project location. Again, I put in the same Mendoza project in ArcSWAT, and Mendoza project would be the location, and finish. So what SWATCUP is doing now is bringing in your text in out file, and so let me go here. Here we just use this icon to build a new project. Here is a list of your previous projects. You can open an older project. I will tell you about the import outlets a bit later. Restore files from backup, I will tell you in a minute. Open project folder in Window Explorer. So in case you forgot where your project is, if you press that one, it'll bring you to the project. So I have my Mendoza project, I have the database, I have SWATCUP, and I have ArcSWAT, right? Everything in the same folder. So what happened here? So if I open my SWATCUP project, as I said before, we have a backup folder. This backup folder contains all of your SWAT files, right? So SWAT needs these files to run. And if I go down here, I said that before that what I will do is actually go here and delete all these outputs, which was the result of the first run when you were in ArcSWAT. So delete this because we don't want to be carrying these everywhere. So, and they're not useful here anyhow. This folder should only contain your SWAT input files. So I delete all these output files, which are so nicely called output HRU, output pesticide, reach, and reservoir, and so on. So let's delete those. There is also another file which doesn't start with output for some reason. That's this file. Sometimes this file can get very large. Here it's not too large, but you should also delete this, so that in this backup folder I only have, this is also something that we don't need. It's only the SWAT input files are here. So that's the backup. Echo, it's still empty. Iterations, still we haven't made any iterations. Parallel processing, and then SPE in, it's all the input files, and SPE out, and then the rest of the files. So your text in out is copied here once, and it's copied here in the working folder, right? In the working folder. This is the folder where all the parameters keep changing. When you do calibration, what you're doing is changing the parameters and running the model. If you remember, I said that before in the first video. You change the parameters, you run the model. You change the parameters, you run the model. So in this folder, this is the active folder. Parameters get changed here. So at any given time, the parameters that exist in these files is the result of the last simulation that you made. It's very important that you keep that in mind, that the parameters keep changing here, but they are always fixed in backup unless you change them for some reason. But the parameters that are in this folder, in these files here, they keep changing. And sometimes you want to go back, sometimes you just play around and you want to go back. You can go and grab the initial file from the backup and put it here. Now, maybe we come across this later when we are doing some other examples. So this is initially what happened, is that it created a folder, a SWAT-CUP folder, put the initial text in out here and a copy here. Now, the next thing I want to do is to define parameters and input data for my project, right? The project that we are building now. So what I do is you just have to go through here one by one and edit. Initially, when you create a new project, some default parameters, some initial parameters are brought in just as an example. Just as an example to show you what you should be doing, what it looks like. But you've got to edit this for your project. I see many people just use this to run their model. This is not the idea. This is not what you should do. You should be editing these files for your project and choosing the parameters that are important for your project, as I will explain now. So we need to edit these files which are here for our project. The first file is parameter information file. In this file, you have the number of parameters that you want to fit and the number of simulations that you want to make. Normally, we would make anywhere between 300 to 700 simulations, depending on the speed of SWAT, your project, the number of parameters, and so on and so forth. That's about the number of, on the average, you need to make about 500 simulations, right? Not 20 simulations, right? Parinf has two forms. There is a form view like this, and there is a text view. I am more comfortable with the text view because I know the syntax. I know how to write the parameters, and I've given some examples here of how the syntax goes, and there is more in the manual. But the form view I made just that it can help you to build, so you don't know how to write a parameter. So if I go here and I say I want to add a new parameter, then it brings me to this window here where all the SWAT parameters should be here. I think every one of them. There may be some new ones which are not here, but most of them are here. And if I go to basin, then I get all the basin files. If I go to groundwater, then I will get all the groundwater files. So if I want to add, for example, groundwater recharge of deep aquifer, then I just choose that and OK, and it comes here. And immediately it comes in the text view also. So whatever I do in the text or in the form, it will show in the other one. So here you can set the method, whether it's relative change or state minimum maximum. What is the hydrologic group? What is the soil texture? I have covered this, so I'm not going to go through this again. You should go to the first video and also the manual. You get the definition of these. and so on. So this helps you to, so whatever I write here, by the logic group, for example, A, and I want sub-basins of 1 to 5 and so on. So whatever that I do here, it will show up here. So it's just something to help you to build the syntax of a parameter that you want to change. So for my project, the first thing you do is not to go right away to calibrate. Some people just pick 20 parameters, whatever they can, they put it here. It's not a soup, right? You have to choose parameters based on your need and not just select everything and put it here, and then of course the SWAT crashes and then I get email that what happened. So the first thing you do is to run your model as it is before any calibration, so that you know whether your model can be calibrated or not. Maybe it's not even calibrable, as I said in the first video. So what I'm going to do is I choose one parameter and one simulation, and I'm going to pick, I gave here an example, I pick a parameter that is really has no effect. This parameter is initially 0 and it's hardly used. It is in basin, and I just copy this from here and I paste it here, and I can even make it a relative change. Now I can repeat again that the relative change, it multiplies the existing number but by 1 plus a number within this range, right? So it changes if it's in the basin, if it is in the sub, it changes the parameters in every sub basin, right, if I leave it like this. So you have to be careful. Soil parameters, CN2, these are spatial parameters. So you don't want to have a value and change it all over the place and put it with the same value, right? Then you will lose completely your spatial heterogeneity. So you have to be careful with this, and please read the manual about this. Now, if I say a relative change to this parameter from 0 to 0, that means it's not changing anything, right? This is just a trick to this program so that it gives you the first simulation. So I use one parameter, one simulation, and this is my parameter. Now the program reads the number of parameters you state here. So if I say 1, it just reads this one. It doesn't care about the rest. So you can either leave this here or whatever, delete them or whatever you want, or you just keep them here to show you what you have been doing in the past. These are some examples. You can just let it be. So this is how my parinf for the first simulation looks like. Then I go to SPSW edit. This SWAT edit is, I will show you the uses of this, but initially you have to, the starting simulation number is 1 and the ending simulation number is 1. I just want to make one simulation. Then file CIO, I put here, this is a SWAT file, right? And just for reference for you, because it's important to know the dates. Now, a lot of people make error with the dates. I even made a video, the first error video, it's about timing. The timing is really very simple. Here, SWAT tells you the number of simulated years. You're simulating for 9 years. Beginning simulation is 1996. But if you go down here, it's the number of years you skip. You should have 2-3 years of skip. In these years, SWAT simulates the model to set some initial conditions, but it doesn't write it. So it doesn't appear in the input file. So the input file begins from 1999, right? 96, 97, 98 is not written. So input file begins from 1999, and SWAT-CUP cares about the input file, right? Not the beginning of, you could have 20 years of warm-up period, skip period, so that doesn't mean anything to SWAT-CUP. So in SWAT-CUP, you go from 1999 to 2004, right? 1996 plus 9, it's the end year of simulation is 2004. So that's what that is what you want. It's and those are what your years are. So it is very important that you keep this simple concept in mind. The next file here is absolute SWAT values. In this file, again, I have all the SWAT parameters, maybe almost all. The new ones, again, are not here. And this gives you the absolute range that a parameter can change within this absolute range. So SWAT-CUP does not allow any parameter values outside of this range to go into the SWAT files. So if it's less than 0, it'll put it to 0. If it's more than 5,000, it'll put it to 5,000. You can edit this, right? This is if you have some idea of what the range should be in your region, the absolute range, then you can edit this file. The next is observations. Observations are many observation files you can have. Any SWAT output file, maybe you have measurements from reach files, from HRU files, from sub files. I'm not going to go through these files. These are SWAT files. You know what's in there. Sediment file, reservoir file, and soil moisture file. So if you have measured soil moisture and you would like to use that to calibrate, then you would like to edit this file. But if you only have discharge only is in reach file. So all you care about is reach. So if I activate this, the observed reach gets activated, and I can edit this, right? So I go into this file. This is again an example that I have here to show you the format. It says the number of observed variables. In our case, we only have one discharge. So I say 1. And then I go to my folder again and see where my data, discharge data is. So I have in Mendoza Prime, my database is here, my discharge is here. If I go to the measured discharge, here is the raw measured discharge data. For me, I have monthly, daily, and daily values. So let's use monthly values. So here is the month. Let me get rid of this filter. So this is how it looks like. I have month, date, flow. Month is a sequential number from the first month, the first day, or the first year of SWAT simulation. It began in 1999, as I said, and it ended in 2004. So it should begin from beginning of the month and end at the end of the month in a year. So here, this middle column is arbitrary. You have to give something here which means something to you, and I usually put just the date here. And it should be one continuous text. And this is the flow. So I have some missing data here, and then I have flow. So to make the SWAT-CUP file is really very easy. If your data looks something like this, then you can just filter that 1999 away, and what is left is the data that you have. And it begins from 3 because 1 and 2, month 1 and 2 is missing. So I just copy this, very simple, and paste it into my SWAT-CUP and paste it here. So I paste the data here, and in the Excel file it said that it's from subbasin number 7, so I just call it Q7. Whatever you call it, you should call it with the same name everywhere. So I have discharge from subbasin 7. How many data points? So if I just copy this, if I just paste it here, I can see how many data points from month 3, 4, 5 is missing. So I have how many? 69 data points, right? So this number here is the number of data points, 69, that appears down here. Now that's all. That's my observation file. Now I can go down here. If I said I have one variable, right, just this, then SWAT-CUP reads only one variable. It doesn't care about the rest of this. So initially I had about 16 parameters here, and I had subbasins from discharge from different subbasins. I had nitrate from different subbasins, and so on. So I had 16 different variables, but this time we only have one. I can either leave those or delete them. So I'm just going to delete it so I don't have such a large file. If I can. So from here all the way to the end. Okay, I don't need this, so I delete them. So this is my observation file. Now the next thing is extraction. So what I would like to do is extract from outputs of SWAT the same values so that I can compare them, right? So I need to extract from output of SWAT. Here we have two files. One is the name of the file that the extracted values should be written to, and I call it with the same name. I have Q7. So these names should be kept the same everywhere. So that's my file name. And then I have instructions on what to extract and from where. So I want to extract from output.reach file. In this example that I gave, I have two variables. I have flow and I have nitrate. These are column numbers 7 and 18 in this file. You just open that SWAT file and count the number of columns until this is Q out and this is nitrate, until the variable that you want. And then here is the number of subbasins. So let me just edit this for my case. So I have one variable and I have only column number 7, which is flow out. Number of discharges, number of subbasins. So I can just go to my project easily and find out what the number of subbasins are. So if I go here to the end, I can find this out from many places, and one of them is just here. These are all my SWAT files. As you know, this is the number of subbasin, and that's the number of HRU in that subbasin. So I have 17 subbasins in this project. So I'll just say I have 17 subbasins. Now here it says for subbasin, the number of subbasins to get for the first variable. So my first variable, which is the discharge, I may have discharge from different subbasins, measured discharge from different subbasins in my basin, right? But in this case I have one, so I just say I have one. And it says that what is the subbasin number. So if I go back to here where I have my discharge data, here it says it's from subbasin number 7, right? So I just have to say I have 1 from subbasin number 7. This is for the second variable. In the example was nitrate. Now if you have more variables, you just copy and paste. Say if you have sediment also. If you have ET or whatever you have, you just copy and paste as many variables as you have. In this case I have just one, so I can just delete these. And then I have to write the date, very important. The date, as you recall in file CIO, it's SWAT begins in 96, but 3 years of warm-up, so it's 99, right? And my data in the observed file is also from 1999 to 2004. So I have to write here, my data is from 1999. The end year is 2004, and it is monthly, 2 for monthly. So that's that file. Let me go down. The next one is objective function. You may have many variables, but you may only want to use a few of them or all of them in your objective function. So the observe file contains what you want to include in the objective function, which variables. So in the example, again, I had 16 variables, but now I have only one variable. So I edit this to 1. This is the objective function type. So 1, as I said, if you go to help and open your manual, and then you can go here down to objective functions, and there's 11 different objective functions that you can choose from. And here we have the multiplicative. One is multiplicative form of the error function here, the average of the square of the differences. So if you have many variables, that's how they look like. They get all multiplied together. In the summation form, you can sum them, but you have to give them a weight and calculate the weight like this. And then you have the R squared, of course. Then you have the chi-squared that you can use. You have the Nash-Sutcliffe that you can use, and so on. There is BR squared, which is also quite nice, I think. You have SSQR. Please look in the manual. You have P-bias and KGE, and you have RSR and modified Nash-Sutcliffe with the coefficient P that you need to specify. So those are the objective functions. So I have 5 here, that means Nash-Sutcliffe. Now the next line is for multi-objective objective functions. So if you want to build an objective function made up of R squared, Nash-Sutcliffe, P-bias, RSR, or whatever you want, any combination of these you can use to build an objective function. And these are the coefficients of those objective functions. In the manual at the beginning, I have sort of 2 short pages that describes this is the kind of objective or multi-objective functions that I have in the program. You have a combination of all these 11 files, right? And any weight that is 0, so that is not counted. But the ones that are not 0, you have to calculate or give a weight, which I'll show you later. Now, I have formulated this multi-objective or multi-goal function, which is a combination of R squared, Nash-Sutcliffe, and P-bias. I'll show you later why it is important to have a multi-objective, and then these are how the weights are calculated, and I'll show you where these weights are later. Now, so that line is for that. Now, this here is the minimum value of objective function threshold for behavioral solution. So in this SWAT-CUP Premium, you have multi-objective and you have behavioral objective. Behavioral objective is you would like to collect all the parameters whose objective function is better than a certain value. Say if we have Nash-Sutcliffe, then I put this to 0.7. So I would like all the solutions which have Nash-Sutcliffe of better than 0.7 in my calibrated model, right? So that means I could have hundreds of parameter sets with Nash-Sutcliffe higher than 0.7 and all of those acceptable solutions. So again, you can see that this concept of the best really is meaningless. If you have one best, you can have thousands of bests, right? So this is for that type of objective function. And the last number here is the power of that modified Nash-Sutcliffe, as I showed you before. So let's edit this for our case. So I have Q of 7. This is the weight of variables in the objective function. What that means is if I go back to my file here, and for some of the objective functions, of course, that weight is important. For example, if you choose number 1, the multiplicative form, there is no weight. Here, the sum form, there is a weight. And we need to add a weight because the value, the magnitude of sediment is much, much larger than discharge. Or nitrate could be much larger than discharge. And if I don't give it any weight, then clearly sediment will dominate the optimization process. So I give them a weight. So I give this a higher weight and this a higher weight so that they each have equal contribution to the objective function, so that my solution has a sort of a relatively good simulation of discharge, sediment, and nitrate, and it doesn't only try to fit sediment to the detriment of discharge or nitrate. So in some cases, for example, for R-squared is not that important because the value of objective function changes between 0 and 1. It's not a big difference. But for Nash-Sutcliffe, it could be important because Nash-Sutcliffe ranges from -infinity to +1. And if there is one very bad simulation, you can have Nash-Sutcliffe of -300, -400, and that will dominate the process, and you don't want that. That's why sometimes it's important to give the weights. So this is that weight. The next two accounts for if you want to have flow separation or not. The first one is dynamic flow separation. The second one is constant flow separation. Again, let me quickly tell you that flow separation, the idea is that similar to two variables, if you have, I have to find it here somewhere, you can just search for it maybe. Let us search for it. Flow separation. Okay, base flow separation is here. So if I have a signal like this, right? Again, I have peaks and I have base flow. The peaks may dominate my optimization process, right? So if you want to have a solution which is relatively good in peaks and relatively good with base, then you need to break this into two variables, right? Anything less than 35 is the lower part, and anything above 35 is the higher part, and then you give a larger weight to the lower part, right? So that they have equal contribution again to the objective function. So this way, if it is static, then you just give one value, right? If it is dynamic, then you have to run a program. There are programs in, I think, in SWAT website that base flow separation, they're called. Then you will calculate the peak flow and the base flows. And then in that case, if it's a dynamic one, you need another column here that has the base flow. I think an example of that I should have in the input here. Here is an example of dynamic flow where you have your flow and then you have the base flow. That would be another column, right? Now, then this is, if constant, then this is the weight of the lower and this is the weight of the higher part of your flow, right? And then the next row is percent. This should be percent error. The percent error in flow is around plus and minus 10%. Now, if you have a better information about your instrument that measured the flow, you can add that here. And I'll show you later how this is accounted for. But usually we can safely assume a discharge measurement error of about 10%. And then the next is just the number of observations. Again, remember we had 69, and I'm just going to go to this observe file, and it's the same 69. So I just copy this and pasted the control copy, and here control V. And again, I can either leave these or I can delete them. So let's just leave it. So because I have one variable, it only reads one and doesn't care about the rest. And these spaces in between and so are not very important. But here, this should be a continuous string, right? And the overall format should be kept. So we should not attach this one to this one or this one to this one. Keep the overall format, but the lines and so on, spaces are not that important. So I have created the two most important files. That's the observed and this observation for extraction. And then again, I have the variable name here. So again, I have only Q7, so I can delete the rest or not. And then up to here, let me save everything that we have done. And let me close some of these. We have more room, so we did objective function. The next one is no observation. No observation, you can extract variables from SWAT output files that you have no observation for. So if you're calibrating with discharge, but you want to know what nitrate, what sediment, what crop yield it's giving, its SWAT is giving, so you can extract those. There is no observation, so that's why it's called no observation extraction. The input, extraction input is exactly similar to the one I showed you before. So maybe later we can look at this. Now the next part are the executable files. This is the engine of SWAT-CUP. So these files look a bit scary when you open them, but there is nothing. This is just deleting from the folders from the previous runs. The most important thing here is that the program runs the Latin hypercube sampling, and I covered this in, I think, video number 3, that how that is. So you need to sample. Then in the next one you run, so you don't need to change these. In the other file is a single objective post-processing. So you have single objective post-processing, single objective behavioral post-processing, multi-objective post-processing, and multi-objective behavioral post-processing. So you have these 4 different options for how you want to do the post-processing. The single objective post-processing is similar to SUFI 2. So if you use this, it's like you're using SUFI 2. And then this just deletes some previous outputs, and then it runs the goal function, calculates the objective function, calculates new parameters, and calculates the 95 PPU. SPE is iterative, so you have to do like 3-4 iterations, and at each iteration it gives you what would be the best parameters, these parameter ranges to use for the next iteration. Those appear here. And then you use that and you make another iteration. So after 3-4 iterations, you should come to some optimum calibration results. And then you have the no observation post-processing that gives you the 95 PPU when you have no observation. We don't want to run this now, so I'm just going to uncheck this. Then you have the SPE extract batch file. This is, you can extract from any of these, as I have discussed. Let me uncheck the no observation one. So we only have data from the reach file that we want to extract, so you can just check that one, and don't worry about this optional or no optional. Don't worry about that for now. Then we have validation. Again, you have single objective validation, behavioral validation, multi-objective validation, and so on. So that validation, we'll discuss that later. So that's all. That's all you need. It's really not that difficult. It's very easy, just a few simple files, text files that you have to fill. So I'm going to save all. I'm going to close all. You should do that always before you make a run. So the important thing to check is that my parinf, I'm doing one simulation with one parameter, and my SWEdit file has one beginning and one ending. So I'm just going to do a run. So I do the pre-processing. Again, this ran the Latin hypercube simulation. Then I do the run. So what it's doing is that it runs, what it happened is that it ran SWAT-edit. This is SWAT-edit. SWAT-edit, it's really an excellent program that changes parameters of your wish, puts them into appropriate folders, files of the SWAT, hundreds of thousands of SWAT input files. And then it runs SWAT, and then it extracts, right? It extracts from the reach and puts it in that file. So it did this. Now I run the post-processing. I use single objective post-processing. Now when you are doing the first run with one simulation, no new parameters are generated, of course, with one simulation. So you get an error here that this matrix is singular, so you don't care about that error. Just say, okay. You only want to see how it looks like. So if I go, let me just close some of this again. So if I go to my output and single objective output and 95 PPU, and that is how my first model run looks like. So this is my observation, the blue line, and this is my simulation. So it doesn't look that great right now, does it? All right, so this video is getting too long. I'm going to stop this and show you how we're going to fix this problem in part 2 of video number 4. Thank you.